what is the electric field due to a charge of ring? Let's say this is a ring and we want to know what is the electric field due to this charge of ring which has total charge Q. The net charge on the ring is Q. What is the electric field intensity at this point, which is x distance from the center of this ring? We want to know the electric field strength at this point. Okay. What we can do? Let's say the radius of this is A. So at this point, if we consider a very small element of this ring here, let's say the charge is dq, then this will have electric field like this. If this is the distance, we know how to calculate it. This electric field E, let's say E dE, let's say this is small electric field because of this small charge. How can we calculate it? You know this very well. dE will be equal to 1 by 4 pi epsilon 0 by Coulomb's law. dq by r square. What is r? R is this. That is under root a square plus x square. This is what? This is under root a square plus x square. So square of this. So this will be a square plus x square. This is the electric field at this point in this direction. Now let's resolve it into x and y component. This is your x component, this is your y component. If this be theta, this is theta, this is d, so this is what? dE cos theta, and this is what? dE sin theta. Okay, your dE is basically this one. What happens about d sin theta? You have d sin theta like this because of this, and if you take here dq, d sin theta will be to this side. So what happens? We don't have net electric field in the y direction. All components in the y direction, because of the lower part, will be cancelled by the y component of the electric field in the lower part, this part, by the upper part of this ring. So that will cancel. So what we'll have? We'll have only this dE cos theta. If this is x direction, this is y direction. So we won't have anything in j. We'll only have electric field in I direction. And this is equal to dE cos theta. So what is cos theta? Let's see. Cos theta will be this x by a square plus x square under root. So what is the electric field in x direction? If we say dEx, this will be this into cos theta. So we can put the value of cos theta here. This will be x dq by, this is half, so this will be 3 by 2. Okay. So electric field in the x direction is this. Now, what we'll have to do? We'll have to find the net electric field. Net electric field, how can we find? By integrating it. Now, you must see, these all are constants. X is constant, a is constant. So you can take them out. This will be x by 4 pi epsilon 0, a square plus x square, 3 by 2. These are constants. So you have only dq, and if you integrate dq complete, you'll get q. So what is the electric field? Electric field in the x direction is xq by 4 pi epsilon 0, a square plus x square, 3 by 2. So this is the value of electric field. So if you don't want to put x, then you can say that electric field is this into I cap. We have taken the component of the electric field in the x direction. So this is the value. From here, you can understand at x equal to 0, I'm just rubbing it. At x equal to 0, that is at the center of the ring, this point, your electric field is 0. Why? Very logical. All components will be cancelled out. And x is also 0 at x equal to infinity, or you can say when x tends to infinity, again your electric field is 0. So it is 0 here and at infinite distance. Obviously, there will be a point at which this electric field will be maximum. What you can do, you can take dE by dx. You know how to take maxima and minima. By putting that maxima minima approach, you can find dE by dx equal to 0. Then you can find d2E by dx2 to find whether it is minimum or maximum value. That will be maximum value. You'll see that E will be maximum. I'm not doing that. I have left it for you. You should do dE by dx and then equate it to 0. Find the value. You'll see when x is equal to a by root 2 plus minus. that is to this side or this side, when x is equal to a by root 2, the electric field will be maximum. And you can put the value of x equal to a by root 2 here to find the maximum value of electric field. Okay. So what we saw, we know that the electric field intensity, because of a ring that is of, let's say, radius r, at a distance x from its center, this distance is x. So at a distance x from the center, electric field is in this direction only, ex direction only. This direction y, actually, if we, the electric field is in this direction because of this. So we have y component and x component. Y components cancel because of this and this opposing each other, it cancels. So we only have in x direction. And what is its value? We have derived it in our last example. It is, if the charge on the ring is q, then q x by x square plus r square 3 by 2, and it is in x direction only. So this much we have done. What if it is a disk? That is, it is a ring. What if it is a disk, big disk? That is, we have from here to, let's say, to point r, to this point r. This is the radius of a disk, like this. Okay, so radius is r. Then what? See how we proceed. Let this be a very thin ring of thickness dr. Okay, or not capital R, small r, because we are using this as r. So we have a very thin ring of radius small r, thickness is dr. So the electric field intensity at this point, due to this thin ring of charge, let's say the charge is dq, is this. So that, let's understand what is charge dq. Charge by area is actually equal to the surface charge density. Surface charge density, let it be sigma, small letter sigma. This is capital sigma, this is small sigma. So let this be sigma. Then your charge on this ring is sigma into area of this ring. What will be the area? It will be the product of circumference and this thickness. This thickness is dr. So this is your dq. So we have this small electric field due to this thin ring of charge equal to 1 by 4 pi epsilon 0, charge into this distance. So charge is this dq, that is sigma into 2 pi r dr, okay, into x by x square plus r square 3 by 2. Now see, 2 pi cancels this, and we know x is constant. What varies? R varies. R varies from 0 to capital R, that is the radius of the sheet. If we are talking of this sheet, R will vary from 0 to capital R. So when we, let me first of all write this, variable is only R. So we can take x out, that is sigma, then x, and then you have 2 epsilon 0. Okay, 2 epsilon 0. And here you have sigma, you have taken this. So this is dr by x square plus r square to the power 3 by 2. So if you want to take ex, you will integrate it from 0 to r. Now, how to solve this? Let's take z equal to r square plus x square. X is constant, so dz will be equal to 2r dr. 2r dr. This is, so what we can write is, we can write ex is equal to sigma x by 2 epsilon 0, this is 0. So when r is 0, this will be x square, and when this is r, so this is r square plus x square, okay. And r dr is dz by 2, so this is dz, and here what you have, this is z, so z to the power 3 by 2, okay. Then you can write sigma x by 4 epsilon 0, this is what? This will be z to the power minus 3 by 2 plus 1 by minus 3 by 2 plus 1. This is the way to integrate. What is the meaning? This is half, that is 1 by root z, and this is minus half. So I am putting it here minus and here 2, so that you get this as 1 by root over r square plus x square. No, not r square plus x square, z, root over z. This is what you get. Okay, minus I have taken out of this. So finally what you get, not 0, it is x square from 2 r square plus x square. So what you get is, here you will get sigma x by 2 epsilon 0, and here you will get this is minus, so in reverse, that is 1 by x square. You get 1 by x square minus 1 by root over r square plus x square. This is root of this, so this will be 1 by x. Clear? This is x square. Root of x square is this. So what do we get? I'm putting this. So Ex will be equal to sigma by 2 epsilon 0. X goes to this side, it becomes 1. And then here you get x by root over x square plus r square. So this is the electric field intensity due to this sheet which has charge, with surface charge density sigma. Clear? This is what we get. This is the expression, and we have only in x direction electric field intensity. We have electric field intensity only in the x direction. Why? Because in the y direction, all the components from upper side will be to the lower side in the y direction, that is to minus y, and from the lower side it will be to plus y direction. So they'll cancel out. We'll get electric field intensity in the x direction only, that is this. Okay. Now we have a very unique and very valuable expression from here. What it is? See, if R, this sheet, is greater than x, that is, if we are talking of a sheet which is, let's say, which has a radius of 100 meters, and we are talking of distance of, let's say, 1 meter. So this is far greater than this. Then what? See, this is x by root over x square plus r square, or you can take x square out of this, so that you will get x 1 plus r square by x square. So this is 1. When r is greater than this, this expression will be 0, so that your electric field intensity will be simply sigma by 2 epsilon 0. Now this is a very important expression. Why? Because if we have an infinitely large sheet, whether it has a radius r or it is a square sheet, it doesn't matter. So when we are talking of a distance very small to the length and breadth of the sheet, then the electric field intensity near to that sheet will be sigma by 2 epsilon 0, that is independent of the distance of that point from the sheet. Clear? And what is the meaning of infinity? Infinity means if your x is 1 by 100th of the radius, that is the meaning of infinity. So this is a very important expression. Clear? Let's deduce the expression for electric field intensity due to a long wire. Okay, so let that wire be this, and from this point, let's say we have to see what is the electric field intensity because of this wire at a point which is, let's say this distance is x. So at a point which is x distance from this wire, what is the electric field intensity? Okay, so let's what we are given with is lambda, the linear charge density. Linear charge density means if the total charge on this is q by, if the total length of the wire is L, so q by L is lambda. So let's consider a small length dl, so that your dq, the charge at this point, is lambda dl. Okay, so because of this, what is the electric field at this point? This is electric field at this point, E, or say dE. So we'll have two components, x and y. This is dx and this is dEy. Let's say this is theta, and let's say this is L from here to here. What is the electric field intensity dE? dE will be 1 by 4 pi epsilon 0 q by r square. This is what we know of electric field intensity. So what is q? Q is lambda dl. Lambda dl by r square, that is this square. Let's say this is r. So r is what? It is L square plus x square root over L square plus x square of this, or it is simply r square. I'm writing it r square. You'll understand why. Now we have taken this as angle theta. So what is r? See, x by r, b by h, base by hypotenuse. This is cos theta. This means x is what? R cos theta. That is, r is x sec theta. So r square means x sec square theta. X is constant. Secondly, this is dl. But what is L? L is, see, L by r is sin theta. This means L is r sin theta. So dl is what? dl will be r, this sin theta becomes cos theta d theta. Okay, so we can put it here, but it is of no use. Why? Because we have taken r here, and r is not a constant. This will be variable, this will be variable. So let's take different trigonometric expression. What we can take? This is constant. So let's take on the basis of this L by x, that is perpendicular by base, that is tan theta. So we can say L is x tan theta. Now theta is variable, but x is constant. So dl will be x, this is sec square theta d theta. So let's write this in place of dl. This is x sec square, this sec square theta d theta. Okay, so sec square cancels, x cancels this. So what are we left with? We are left with lambda by 4 pi epsilon 0 x. This was x sec theta and r square. So x square sec square theta, 4 pi epsilon 0 x. Lambda is out. What we have? We have simply d theta. So this is the expression for dE. This is dE, electric field intensity due to this small charge. Okay. Now there are two components of this dE, dEx and dEy. What will be? Let me write dEx here first. dE here. This is lambda x d theta. Now we have two components, dEx as cos theta. This is theta. So dEx will be dE cos theta, that is lambda by 4 pi epsilon 0 x cos theta d theta. Okay, and we have the y component, that is lambda by 4 pi epsilon 0 x sin theta d theta. Now if this is a very long wire, let's take condition 1 or case 1. When the wire is infinitely long, that is, it is a very long wire, then it means this will be from pi by 2, see 0 to pi by 2 and 0 to minus pi by 2. That is what we'll have to do. We'll have to integrate. And secondly, I forgot, if it is infinitely long, this will go from 0 to pi by 2, and here from 0 to minus pi by 2, and this y component will cancel out. Because of the upper part we have y component in the lower part, and because of the lower part of the wire we have component in the upper part. They will cancel out. We'll only have in x direction. So in this case, your electric field in y direction will be 0, and electric field in x direction will be where? It will be, you can do two things. Either you can take from minus pi by 2 to pi by 2, or you can take twice of this. This, if whatever be the electric field because of this x component, because of this will be same. So you can take 2 of lambda by 4 pi epsilon 0 x cos theta d theta from 0 to pi by 2. If you know about odd even functions, we could have taken from minus pi by 2 to pi by 2 also. So what do we get? Cos theta, I am rubbing it. Cos theta, it comes to, integration comes to sin theta, and it is from 0 to pi by 2. This means 1 minus 0. So this is 1. So what do we get finally? Ex is equal to, see, just 2. So this will be lambda by 2 pi epsilon 0 x. Okay. So this is the electric field intensity if the wire is infinitely long, Second, what if case 2, you should keep this in mind. Now case 2, when this is not infinitely long, we have, let's say this is theta 1, this is theta 2, that is from theta 1 to theta 2. Then what? See, Ex in the x direction, we have lambda 4 by epsilon 0 x d theta, it was cos theta. So cos theta d theta from theta 1 to theta 2. What you get? This will be sin theta. So this will be lambda sin theta 2 minus sin theta 1 by 4 pi epsilon 0 x. So this is in x direction, and in y direction, this is only sin theta, that will be minus cos theta. So this will be reverse. So what you will get is cos theta 1 minus cos theta 2 by 4 pi epsilon 0 x. So this is in x direction, this is in y direction. And I'm rubbing this. If you want to see the net electric field, what you can do? Net electric field, the magnitude of the net electric field will be under root Ex square plus Ey square. So you have Ex and Ey. This component you can take out, and then sin theta 2 minus sin theta 1, square of that, cos theta, and you can get the value. And tan theta, if you want to see what is the angle of the electric field, let's say tan phi, that will be equal to Ey by Ex. Okay. So this is how we calculate the electric field intensity due to a long wire. So I have discussed many conceptual topics. So if you have understood this properly, you will be able to solve any problem that you need to solve by this method. Okay, later on we will see Gauss's law, and we will see this is a lot more easier to find than these methods, this very detailed method. That is a very shortcut method.